Okay, this is cs212. It's the programming language. We're going to talking about the languages. The languages is composed of a symbol. Symbol can be any character like A, B, C, 1, 2, 3, 4, 5, time, slash, etc. And the alphabet is because a finite of non-empty set of the symbol. Okay, we denote by sigma. For example, if we say sigma equal to A, B, C, 1, 2, 3. If okay, so that is our alphabet that we can in our language we can use this alphabet with we have a symbol is just A, B, C, 1, 2, 3 only. So the string is a finite sequence of symbol in the our alphabet here. For example, if our alphabet we have A, B, C, 1, 2, 3, so that the string we can in our language can be generated from the sigma. Example like if we have a sigma is equal to A, B, C, 1, 2, 3 like this, we can generate a string like A, B, 1, C, B, D, B, 1, 2, 3, 1, 1 like this. It can generate from this sigma only. Or we can have A, B, B, or we can have a B, 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 A, B, C, 2, 3, 1 like this. But if our sigma is equal A, B, C, 1, 2, 3, we cannot generate like we cannot have a string like A, B, D, E, F. We cannot have this one because our sigma only have a symbol is A, B, C, and 1, 2, 3. We have a special string. We call it empty string. We denote by symbol is lambda. Okay, then we have a sigma. We call this symbol is sigma star. Sigma star is the set of all string over the alphabet. So then this lambda is always be in the sigma star. We start with sigma star. We start with lambda. If we have is for example here, if we have sigma equal to A and B, so then sigma star here. This is sigma star. Sigma star is B A and B star. We can generate. This means we can generate all the string with combination between A and B. So we can have lambda. Okay, number of character in the string we call is the length. We call is the length of the string here. For example, here lambda. If we say lambda is the empty string, is mean is nothing. It's have nothing, but it's the special string. So that is length lambda length is equal to 0. It's the null string. So for this one, A is the length is equal 1. B the length is equal 1. So then AA is length equal 2. This one AB is length equal 2 also. For the length equal to 3, like we say A, or we can have A, or B, A like this is the combination between A and B. So then we can have a string from length 0 to infinity. So we define our language is the set of string defined over sigma. Okay, then this means that our language can be the string that we generate from sigma. Okay. If our sigma is equal to a b, so our language can have a string with the symbol is a and b only. Okay, the length of the string we say length 0 we have a lambda. Lambda must be in the sigma star all the time. Length 1 is like a b c. So if we have a b c, it means that now our sigma, okay, our sigma is a b c. We have three symbol a b and c. So the length 1 is a b and c. Length 2 is A B A Z, B A B B B C, C A C B, and C C. So that is length 2. For the length 3 is we have A B, A A C, like this is combination between A, B, and C, etc. For example, here, if we have a string, if we have 0, 1, 1, 0, 0, 1, another one we have lambda and 1 0. Okay, so that this all string is the subset of a 0 and 1 star. For example, here if we have a sigma star is 0 and 1 star, we can say that it's 0 1 1 0 1 is the subset of this set here. So what is this set here is sigma star equal to 0 1 star. So that equal to lambda 0 1 0 0 0 1 1 0 1 1, and we have 0 0 0 0 0 0 1, yes, etc. So now we say 0 1 1. Here is we have 0, we have 1 1 here, we have 0 0 1. So that means this set is the subset of the 0 1 star here. For this set we have lambda and 1 0. We have the 0 1 star here. We have lambda, we have 1 0 here. So that means is this set is the subset of the 0 1 star. Okay, when the language is have a set of string, so then we can use the operator of the set. So that the first operator here is we say union. If we have a language L1 and a language L2, we say L1 union L2. It's the property of the union of the language is the same thing as we have a union of the set. For example, here, if we looking for the Venn diagram here, this is Venn diagram. If we have set A and this is set B, A union B is the whole element in A with the whole element in B. So that is A union B. For example, if we have A is the set of 1, 2, 3, 4, 5, yes, and B equal to 2, 4, 6, 8, like this. So that means A union B. A union B is we take all the element in A and all the element in B become the element of A union B. But if we have the same elements, we take one. For example, here, 1 is in A, but 1 is not in B, so then we take 1. but we have 2 in A, 2 also be in B. We just take 1. Okay, so that we got 2 like this. And we take 3 and 4 is in both A and B, so then we take 1. It's 4. Then 5, 6, and 8. So that is our A union B here. The same thing in here. If we have a language L1 and a language L2, L1 union L2 is be a string in L1 or a string in L2. It's be a set of L1 union L2. So that is mean X is in L1 or X is in L2. X is the string. If X is the string, it means the string is in L1 or string in L2 also. Okay. Then the intersection is if we're looking for the Venn diagram here, yes, if this is A and this is B, okay. A intersection B is mean that the element that is both in A and B here. This is the intersection. We call that is A intersection B. Okay. For example, here, if we have A is this set is 1, 2, 3, 4, 5, and B is 2, 4, 6, 8. So that A intersection B is which the element that's both in A and B. So that is 2. Okay. So that we have 2 because 2 is in A and 2 also be in B also. And what we have is 4. Yes. So now 2 and 4 is the A intersection B. But if A and B is not have any element that both in A and B, so that we say that A intersection B should be equal to empty set. A intersection B equal to empty set here. If we're looking for the Venn diagram for the empty sets here, it means that A not across with B, so that we have A and we have B like this. There's no any element in A also be in B or any element in B also be in A. So that is the empty set for A intersection B. Okay. Here, if you have a language L1 and L2, so then L1 intersection L2 is referred to the language that the string are both in L1 and L2. So that if X is the string, X is must be in L1 and X must be in L2. Okay. Then another operator is complementation. If we say complementation, is mean the element is if we have a set A, so then the complement of A is the all the element is not in A here. If we're looking for Venn diagram here, if this A complement is outside here, this is A complement, this is A complement. We use the symbol is bar here. A bar is the A complement. All the element is not in A here, so that is the A complement. So that if our language of L is over sigma here, we say L complement is the language that consists of all string over sigma star that not in L. So X is the string that not in L but is in the sigma star. Okay, let's look at for the example here. If we have L1 is equal to lambda 0, 1. L2 is equal to lambda 0, 1, and 1, 1. L1 union L2 is equal to, if we say union, it means all the element in L1 and all the element in L2 must be in the union set here. We have L1 equal to lambda 0, 1. So then lambda is in L1 and L2, so we take just 1. So then we have lambda here. 0, we take 0. 1, take 1. And 0, 1 just be in L2. So then we take 0, 1. And then 1, 1 is just only in L2, so then we take it 1, 1 here. So that is mean this set is L1 union L2. Okay, so then the intersection L1 intersection L2. Now we're looking for the string that be in L1 and L2. So we take lambda is in L1 and also lambda is also be in L2. So then we have lambda 0, 0 just in L1 but 0 not in L2. So now we don't take 0. 1 is just in L1 but not in L2. So then we don't take 1. Also 0, 1 is just be in L2 not in L1. So we don't take it. Also 1, 1, 1, 1 is in L2 but not in L1. Okay. So then we don't take 1, 1. So that we only have a lambda for L1 intersection L2. Then we have L bar. It means L1 bar is mean the complement of L1. For this one, for this example here, we just say our sigma is equal to 0 and 1. Then our sigma star, it should be 0 and 1 star. So that means it is equal to lambda 0, 1, and 0, 0, 0, 1, 1, 0, 1, 1, and then 0, 0, 0, 0, 0, 1, 0, 1, 0, like this. So that is our sigma star. So that the L1 complement is the element that is not in L1, but our L1 is lambda 0 and 1. So we take this symbol out of the sigma star. So now we say L1 lambda is in L1. So then we cross this one out. Lambda 0 is in L1. So then we cross this one out. 1 is in L1. So then we cross this one out. So now our complement of L1 is equal to, we start with 0, 0. And then we have 0, 1, 1, 0, 1, 1, 0, 0, 0, 0, 1, etc. Another operator is the set of difference. Okay, if we say the difference of L1 and L2, we say this L1 minus L2. If we have L1 and L2, it means that the element in L1 but not in L2. All the elements just be in L1 but not in L2. Okay, let's look at a Venn diagram here. If this one is A and this one is B, so then A set of difference of between A and B, we say A minus B. A minus B. What is A minus B? Is all the element in A here. All the element in A here. But it's not in B. Here is B A also be in B, so that we don't take it. So the whole part outside here is the element of B. So we don't take it. We just take all the element in A, but not in B. So that is equal to A minus B. Okay. So that means X is the string. So then X should be in L1 but not in L2. This one, if we have L1 equal to lambda 1, 0, 1, 1, 1, and we have L2 equal to 1, 0, 1, 101. So we say what we say L1 minus L2. L1 minus L2 is mean the element is in L1 but not in L2. Okay, lambda in L1 is not in L2. So then we take lambda. 1 is in L1, but 1 is in L2. So now we're not taking 1. 0, 1, 0, 1, be in L1 and also be in L2 here. So now we don't take 0, 1. 1, 1, 1, 1 is in L1 but not in L2. We take 1, 1 because we looking for L1 minus L2. So then if all the element in A, we just check all of the element in L1. So now that's all. We don't go further because we already checked every element in L1. So now then the set of L1 minus L2 equal to lambda and 1, 1. Okay, if we say L2 minus L1, L2 minus L1. Okay, now we're looking for the L2 first. 1 also be in L1. So we don't take L1. We don't take 1. 0, 1, 0, 1 in L2 also be in L1. So we don't take it. 101, 101 is in L2 but it's not in L1. So then we take 101. Now we check all the element in L2. Now that's all. We just finish. So then L2 minus L1 is equal to 101. If we say L1 is the set of all even number, so what that means, L1 equal to 0, 2, 4, 6, etc. That's the set of all even number. And we say L2 the set of all number. Let's say we say L2 is equal to 0, 1, 2, 3, 4, 5, etc. If we say L2 minus if we say L2 minus L1, L2 minus L1, so that means all this is L2 minus L1. 0 is in L2 and also be in L1. So we don't take this one. 1 in L2 but not in L1. So then we take 1. 2 in L2 but also in L1. So now we don't take 2. 3, 3 in L2 but not in L1. 4, 4 in L2 and L1. So we don't take it. So then 5. So then just only in L2. So then we take 5. 6, if 6 in L2 also be in L1, so we don't take it. And 7, 7 is just in L2 but not in L1. So then etc. So now we have a pattern here. So that is mean L2 minus L1 is 1, 3, 5, 7, 9, 11. So what that means? That is a odd number. This is the odd number. Okay, another operator we call is concatenation. Concatenation, or we can call is concat. Concat is mean we take two string combined together. Like if we have a x1, for example, if we have a string x1 equal to a, b, c, x2 equal to d, e, f, this. If we say x1 concat x2, we use dot, or we can say x1 concat x2, or we can write it like this, x1 dot x2. Also the same thing here. So then we take to string in x1 first, then take and combine with a x2. So then x1 concat x2 is a, b, c, d, e, f here. This is from x1, this is from x2. Okay, say that if u and v is the string in sigma star, the definition of concatenation of u and v, that if v length of v equal to 0, that means if length of v is 0, so that means v is lambda. You say u concat v equal to u. What does mean? That means lambda concat anything you got itself. For example, if we say lambda concat x1, then you got x1. Or we say if you take x1 concat lambda is also be the same thing here. You got the x1 also. Okay, then we say if length of u and length of v greater than 0. So that means x1 and that means u and v is not lambda. It have something like if you say let u equal to a1, a2 until an, and we say v equal to b1, b2, b3 until bn. Okay, then we say u concat v. We take u first is a until an. We have a until an. Then combine with v. V is b1 to bn. We take b1 to bn here. So that is u concat v.